Good morning, everyone. This is your teacher, Miss Rita. Today we will continue explaining Chapter 3, Lesson 1, Work and Power. So please go ahead and open your books to page 70. Today we will be correcting the homework that you previously had, and we will solve some extra exercises about work. So first we will start by correcting the homework. In exercise 1, for each of the following pictures, you have to determine if there is work done or not. I remind you to decide if yes or no. You have to compare the arrows of the force that is applied and the movement of the object. In figure 1, as you can see, the force and the movement of the yellow ball are in the same direction, which means that in this case we can say that there is work done. In figure 2, as you can see, the movement of the boy and the force that the boy is applying on the bag are not in the same direction, which means that in this case there is no work done. In figure 3, the waiter is holding the plate, so he is applying a force upward. However, he is moving to the right, which means that the arrows are not in the same direction, so we can say there is no work done. Now let's move on and correct exercise 2. You have the given force equal 15 Newton and distance equal 3 meter. The first question is to specify if the boy is doing work or not. If yes, you have to calculate the work that he is doing. So, the boy is pushing to the right, and the table also moves to the right, which means that the force of the boy and the movement of the table are in the same direction, so of course the boy is doing work. To calculate the value, we have to multiply the force by the distance, so we do 15 times 3 equal 45 joules. So the boy is doing a work of 45 joules. In part B, you have the force of the boy, which is 20 Newton, and you have the work that he is doing, which is 35 joules. You have to calculate the distance that the table moved. In order to calculate the distance, we can use the triangle that we previously learned. D is equal to work divided by force equal to 35 joules divided by 20 Newton equal to 1.75 meter. So the table moved 1.75 meter to the right. Now please open your books to page 72, figure 2. You have this picture that you can see in front of you where you have April. She's holding an instrument and trying to give it to her friend. The first part of the question is, if April's friend wanted to help her do less work, where could he stand? So you know that work is equal to force times distance. So if we decrease the distance between April and her friend, she can do less work. So her friend should move lower to reach her. So he should stand on the lower steps, as you can see on the picture. The second part of the question is, if the steps were higher, what would happen to the amount of work that April is doing? So if the steps are higher, it means that the distance between April and April's friend will increase. When the distance increases, the work that she has to do will also increase. Please open your books on page 73, apply it. If you look with me on the picture on the right, you see a climber who is holding his bag. So he is applying a force upward. At the same time, he is climbing up. so the force and the movement are in the same direction. The amount of work that he is doing is 3000 joules. Now the question is, if he adds equipment in his bag, so his bag will become heavier, it will require a bigger force to hold it, and climbs the same height, he would do more, less, or the same amount of work. Since the bag that the climber is holding will become heavier, it will require a bigger force and more work to hold it. The second part of the question is, if the climber's bag stayed the same weight and the climber only climbed half the height, so he is going half the distance, he would do more, less, or the same amount of work. Since the distance decreased, it means that the amount of work that he has to do will be less. Part 3 of the question is, how much work does the climber do if his bag weighs 90 Newton and he climbs to a height of 30 meters? In order to calculate the work, we have to multiply the force by the distance. So we have 90 Newton times 30 meters, we get 2700 joules. Part 4 of the question, on a different trip, the climber's bag weighs twice as much and he climbs twice as high. How many times more work does he do on this bag than the one in part 3? So we have to compare the work that he is doing now to the work that he did in part 3. The word twice means 2 times. So the pack now weighs 2 times its original weight and the distance is 2 times the original distance. So if I want to calculate work, I say work is force times distance equal 2 times 90, which is the original weight, times 2 times 30, which is the original distance. So I get 4 times 90 times 30, and 90 times 30 is the original work, so the new work is 4 times the work in part 3. Page 73, number 1, part A, you have to specify if a waiter that is holding a plate is doing any work. The answer is no, because the force is upward, however the direction of the movement is straightforward. In part C, you have to calculate the work done when a force of 15 Newton is applied and the distance is 5 meters. So we have to multiply the force by the distance. 50 times 5, we get 250 joules. Finally, I need you to copy the following exercises on your copybook and solve them as homework for next time.